Alright, another good example of determinants would be Cramer's rule, because we can describe Cramer's rule in terms of determinants. Alright, so let's try to derive Cramer's rule starting from the 2x2 system. Alright, so we have this system of linear equations, a11x plus a12y equals r1, and a21x plus a22y is equal to r2. Alright, then let's try to solve for x. Alright, so what I'm going to do is I'm going to multiply the first equation by, say, a22. So you would get a11 a22x plus a12 a22y is equal to actually maybe I'll just do r1 a22. Alright, then we multiply the second one, second equation by, say, a12. So you get a12 times a21x plus a12 times a22y is equal to r2 a12. Alright, then we can go through a subtraction. So I'm going to go through a subtraction here. Alright, the reason why I want to do a subtraction here is that since this guy and that guy are exactly the same, so when you do a subtraction it's going to be canceled out. Alright, let's do, I'm going to just factor out the x here. Then I'll write a11 a22 minus a12 times a21 and is equal to, right, and r1 a22 minus r2 a12. Right, then you notice that here this looks familiar. See if we can write this guy in terms of a determinant. This is actually exactly the same thing as the determinant of a matrix a11 a12 a21 a22. Alright, and also this guy right here can be written as the determinant of a matrix R1 a12 and R2 a22. Alright, so we have that. Alright, so if you're looking for x value, all you have to do is that you just have to divide the whole equation by this determinant. So therefore x is equal to, and determinant of r1 r2 r2, then you have a12 a22 divided by the determinant of a11 a12 a21 a22. Right, so that will be the x value. Right, so you can see that on the bottom this is just a coefficient matrix. You can see a11, you see that a11 a12 a21 a22. So you put the determinant of the coefficient matrix, but the numerator is the coefficient matrix, except that here the first row, if you want the x value, we replace the first row by the right hand side, R1 and R2. Alright, so can you guess what the y value would be? So if you want to find the y value, alright, denominator is exactly the same. So you have a determinant of A11, A12, A21, A22, right? Now, instead of replacing the first column, I'm going to replace the second column by R1 and R2 right hand side, and then first column stays the same, A11, A21, right? That will give you actually the y value. You can verify that in exactly the same way, but that is the formula, right? And this Cramer's rule can be applied to a 3x3, 4x4 system. All you have to do is, let's say if you have a 3x3, then you would have, maybe I should write it so this is separate here. If you have a 3x3 system, say A11x plus A12y plus A13z is equal to, say, R1, A21x plus A22y plus A23z is equal to, say, R2, and A31x plus A32y plus A33z is equal to R3. Then, by Cramer's rule, we know that the x can be found by, right? So the denominator is always the same thing. So you just write down the coefficient matrix and then take the determinant of that. So you have A21, A22, A23, A31, A32, A33. Then you just replace the first column, because it's the first variable, by the right hand side, R1, R2, R3, but the rest stays the same. A32, A13, A23, A33. And a y is going to be, can I just say the same thing? I'll just say A on the bottom. It's exactly the same. But here, you replace the second column by R1, R2, R3. Then the rest stays the same. A21, A31, A13, A23, and A33. And the last one, z is going to be, right? So same thing, determinant on the bottom. Then you replace the third column. So you have R1, R2, R3. Then everything else just stays the same. A12, A21, A22, A31, A32. Alright, so that's the Cramer's rule in 3x3 case. So 3x3 Cramer's rule. Right, and you can see that you can extend it to even higher dimensions. Alright, that's it. I hope that this was clear.